Problem 2, find a particular solution of y double prime minus y prime plus 9y equals 3 sine 3t. So first we see that the associated homogeneous equation will be y double prime minus y prime plus 9y equal to 0. And the characteristic equation for this is, or the auxiliary equation is r square minus r plus 9 is equal to 0. So r equal to 1 plus minus 1 minus 4 times 1 times 9 is 36 over 2. And now 1 minus 36 is a negative number. So when you take the square root, you get complex roots. So what is that? Don't know where that came from. Okay. So this will simplify to r is equal to, so when you break up this fraction, you get 1 over 2 plus minus square root 35i over 2. Negative square root 35 can be written as I times square root 35, or square root 35 times I. I is outside. So this is case 3 of the homogeneous system. And so the solution, let's go back to that. So this is this case. And that's the homogeneous solution. So let's say this is for the homogeneous. And A in this case will be 1/2. And B will be square root 35 by 2. And similarly here, be 1/2. And square root 35 by 2. Okay, so now if you look at the right hand side, this is 3 sine 3t. So the basic term is sine 3t. This is 3, this outside 3 is just a constant. That doesn't change the form. So sine 3t, if we go back, we saw that if you have EAT sine 3t, so EAT is missing here. So you can think of this not being there. So it would just be G sine BT plus H cos BT, and B is 3. So G sine BT plus H cos BT. So we can, and then since here the argument is 3t on the right hand side, the sine argument is 3t. And in this case, the arguments are different. They're not 3t, they're something different. So we don't need to multiply by any power of t. And also the e is missing. So it's obvious that these terms do not match this one. So the way they could match is, let's say if this half was missing and it's just a 0, so then e power 0t would just go away. E power 0 is 1. And let's say the second half, instead of square root 35 by 2, that was 3i. So then this would be cos 3t and sine 3t, and then this would be the same form, and then we will need to multiply by t. But in this case, we're okay. So let's go to the next step. So next step is so we can say none of the terms in YH match the right side of the given equation. So YP will take the form you don't need any powers of t, and so YP will just be this basic form. Okay, so it would be G sine 3t plus H cos 3t. Remember, e to the at is missing in the problem, and so it will be missing here. So it'll be G sine bt plus H cos bt. G sine 3t plus H cos 3t. So remember, whether we have a sine or a cosine, the particular solution picks up both the terms. It picks up both sine and cosine. All right, so now the next step is to substitute this in the given equation. And we need two derivatives. So let's calculate the derivatives, or we can just substitute this as such. Substituting in the given equation, we get, so for y, you will substitute yp. So I'll just copy this. That's the given. And for y double prime, we will have, okay, so let's first do the y. Y will be G sine 3t plus H cos 3t. And now y prime is the derivative of this. So let's take the derivative of this. So instead of y prime, we substitute the derivative. So the derivative of G sine 3t will be 3g cos 3t. 3g cos 3t. And the derivative, remember this was a y prime here, so we're taking the derivative of this. So the derivative of the first term is G sine 3t times 3, G cos 3t times 3, and the derivative of cos 3t is negative sine 3t, so this one would be negative 3h sine 3t. Okay, so this we substituted for y prime, and then the first term was y double prime, so that would be the derivative of the y prime. So remember, this one was y prime, so its derivative would be so 3g cos 3t, the derivative of that would be negative 3g sine 3t. Negative 9g sine 3t. And then the derivative of negative 3h sine 3t will be negative 9h cos 3t. That's just calc 1, chain rule. Okay, so now we've substituted. This one was y double prime. That's the second derivative of this expression. This one was y prime. Remember, we had y double prime minus y prime plus 9y equals 3 sine 3t. So the next step will be to simplify the left-hand side. And now let's collect the like terms. So negative 9g sine 3t. And then this one will be plus 9g sine 3t. So the 9g sine 3t's will cancel out. Or, okay, so this one cancels out with the 9g sine 3t. And then we have negative 9h cos 3t. And plus 9h cos 3t, so they will also cancel out. And then we will have negative 3g cos 3t So from here, we will have negative 3g cos 3t, negative 3g cos 3t. And then this one, negative distributes, will become plus 3h sine 3t. And remember, this 9g sine 3t got cancelled with this negative 9g sine 3t, and then 9h cos 3t will get cancelled with this one. So that's all the left-hand side we will be left with. And that's equal to 3 sine 3t on the right side. And now we have to find this is not, we're not done. The reason for substituting in the original equation is that we need to find these constants. These g and h have to be found. And the way we do it from this equation is we compare coefficients of sine 3t on both sides and cosine 3t on both sides. So comparing coefficients of cos 3t on both sides on both sides of the above equation. So on the left side, we have, for cos 3t, we have negative 3g. And on the right side, we have nothing, we don't have a cos term, cos 3t term on the right side, so it's 0. So that gives g equal to 0. And now we will compare coefficients of sine 3t on both sides. And on the left side, we have 3h, and on the right side, we have 3. So the coefficient of sine 3t on the left side is 3h, and the coefficient of sine 3t on the right is 3. So it means 3h is equal to 3. 3h is equal to 3, and that gives h is equal to 1. So now we have both the constants. So we can write the yp now. Yp is this. G was 0, so this part will go away. Say 0 sine 3t, and h was 1. So this simplifies to just cos 3t. Okay, so now let's substitute. Okay,